to Jay. Where's the link? Invite, right?
Yeah,
Missing.
click on the link and then join meeting.
Copy invite link. I'm just going to stick it in the stick it in his own chat. There we go. Get out of the way. I don't know, maybe message him, Mike, if he wants to join.
I can put the Zoom meeting one into the chat as well if you want.
Yeah, if
this
a
is the
couple of us
last one.
message him.
So wait, so you're going to live stream Zoom, right? So I'm just going to share off of Zoom.
Yeah. So
Okay.
Zoom sends the live stream to YouTube, so we'll pick up people there as well. But yeah, people can dial into Zoom.
Okay.
Okay, good.
I don't need to. I'm not going to try to open that on mine because that'll probably kill my laptop.
Yeah, I'll share screen first, and then we can, and then Dave will.
Great. Yeah. Well, whenever you're ready, Chris, if you want to kick it off, the live stream is going and people can
Perfect.
join. We'll probably see people join.
Awesome. Thanks, David. And thank you all for joining today. We're doing a joint one today along with the Denver meetup chapter. So really pleased to have Dave present here today, Michael as well on XBOM and how it works with Hyperledger. And we're looking forward to hearing more. So I'll leave it to you guys to present. And just as a reminder, we're live streaming on YouTube right now as well. And we'll be monitoring the chat and we'll bring up any questions as they come through. Take it away.
All right. Fantastic, everybody. Thank you very much for being here. My name is Michael Holdman, and I'm founder and CEO of Prasaga. Prasaga is it's a blockchain project, and we have two avenues that we're pursuing at this moment. The overall project is for an open permissionless chain that we are now doing a raise for through a token sale. The other side of this started out as a proof of concept for one specific aspect of our technology, and that's what we're going to talk about today, which is the eXtensible blockchain object model. Just real quick history, eXtensible blockchain object model is actually a first-class object model. It's a proven architecture for operating systems for 5 decades now, almost 6. And it's the same underlying functional architecture, although they were modified of both Mac OS X and of Windows. And what we've done is created a way to decentralize a first-class object model, which will allow us to create a single instance class tree. On the open chain, it'll be a single instance globally. On Hyperledger, we're looking at each chain, of course, would have their own global tree for all of the suppliers and all those associated with those specific chains. So we'll jump right into this. We call it beyond smart contracts because that's exactly what we're doing, is going beyond smart contracts. So let me make sure I'm working here. There we go. So the first thing is chain code, and the issues that we discovered are the same exact issues that are sitting in smart contracts as well. They're static, they're not dynamic. Chain code and smart contracts are not easily created or updated. You can create a very simple transactions. In fact, some of the the conversations we've been in are specifically around the fact that they haven't gone past anything complex processes because it's just too difficult or impossible to do. Second, it can take years to create and deploy, multiple FTE years, depending on how many people you have to have on there and what the complexity of it is. The code requires reloading for each new contract. You have to turn up another chain, or you have to take down all nodes and then restart them with a new contract. I know that in I believe, and Dave can talk about this a little better, in HLF 2.0 and above, there's supposed to be a way to dynamically add chain code, but we haven't heard of anybody actually doing that yet. And then the last thing is code has no global repository. So what you're doing is you're going and copying, you're finding a smart contract or chain code somewhere, copying that, putting it pasting it into a text editor, making your edits, and then uploading that chain code. Well, that's the same as writing the Word application every time you want to write a Word document. And we don't agree that that's a efficient way to run. So XBOM, the Extensible Blockchain Object Model. We came onto Hyperledger for one reason. One reason was to prove out the underlying technology that we could, yes, create accounts, which all blockchains have accounts, but we could actually instantiate objects inside those accounts, or assets inside those accounts. So what we've actually built is a decentralized global operating system. We do have it on Hyperledger proven out, and it is a blockchain, an object-oriented blockchain, not an object-oriented programming language. We've moved past there, and again, Dave can talk a little about that. The first review we've had on this was from KC Tam, and he's a well-known instructor in Hyperledger, and he's done some on XBOM, he's done DAML, he's done other types of reviews and such. And what he came down to was the fact that theoretically the developer does not care about the blockchain, as it's well handled by the infrastructure, and the infrastructure we call the class manager infrastructure, which is that piece that goes between the classes and objects, or applications, for lack of a better word of understanding, and the actual blockchain itself. So as the CMI, the class manager infrastructure, advances in the development cycle, and we add more integration pieces to it, at some point we won't care what programming language you write your classes in, your applications in. It will just run on the blockchain, and in this case, Hyperledger. Right now, it is all written in Go, because that's what it was, and we were here to not change anything. Dave will have stories on Go. Okay, so why this? What does it do? Well, first of all, it makes go-to-market 10x faster. We actually expect it to be much more. You're no longer copying and editing and pasting. You're instantiating code, an object, from a class that resides live on the blockchain. You're instantiating that into your account, and then you're changing the parameters or values of it. What kind of asset is it? It could be a spark plug, and there's this bin has 500 million spark plug in it, and you want to fractionalize those out to your supply chain. Whatever it is. It's again, you're just instantiating the code that everybody else is using. So what that also does is it moves away from a lot of the issues, or mitigates a lot of the issues with bugs and malicious code being actually put into the blockchain and into your systems. It's real-time updates with no service interruptions. And Dave is going to show you actually how code is going, or accounts are going to be loaded, how objects will be loaded into accounts, and how assets can be fractionalized and transferred from one account to the other without writing a smart contract. And then it creates a repository of reusable code. Again, it's a single instance class tree. So you're utilizing the underlying classes and then just changing the parameters. And I think one of the real benefits of this is the many-to-many relationship feasibility on here. At this time, what we mean by that is one supplier may have 4 or 5 different OEMs that he's supplying to. And that's great. If say General Motors, Ford, Chrysler, and 2 others in automotive, right? And now if they're not using the same chain, or even if they're on different Hyperledger chains, they have to, each supplier underneath has to support each one of those instances, which is taxing on the operations. With the XBOM, what this allows is the supplier now can have all of the classes from any of the different Hyperledger Fabric chains from any of the different, the IBM blockchain platform, Oracle blockchain platform, whichever. The XBOM doesn't care who owns it or whose platform it is. It just cares that it's Hyperledger. So it's a way to now have the downstream supplier have a more efficient and cost-effective way of working with their upstream suppliers or vendor or customers. So what is XBOM on Hyperledger? What this is an application, blockchain application framework. There's 6 layers to it. Of course, the bottom layer is the nodes. The second layer is a blockchain. In this instance that we're going to be showing, it's Hyperledger. Then you have your class manager infrastructure, and that's that integration between classes and objects and blockchain. That's what allows the two to talk to each other. And XBOM classes and objects. Right now, we are introducing the first 2 major classes and subclasses for fungible asset and smart asset, which allows the transfer of, first of all, the creation of an asset in your account with a number of units that are in that asset, and to be able to fractionalize that and transfer those actual possession over to other accounts. And then there will be times when developers, whether they be core developers or other developers, want to expand within those classes and such, so that developers could integrate within that layer or interact within that layer of XBOM classes and objects. Then layer 2 is the application developers. This is where most of them will hang out. And again, what we're doing is opening up a breadth of the developer world, because they don't have to know Solidity anymore. They don't have to know Golang. They don't have to know the underlying technology of the blockchain. They just have to know how to work with classes and objects in the first class object model, which will just be an education. And then of course the applications is a top layer. So the users and the application developers don't know anything or don't have to know anything from layer 3 down. We've created that ease of development and use. So when we now get into the integration at the peer node stack, you can see where each one of these integrates within the blockchain or how it works on the peer node. Again, the application classes and objects are basically where the developers are playing in and such. The built-in classes are the ones that Dave will talk about somewhat, and as in the creation of, we are not going to, just to let everybody know, go into the first presentation we did for Hyperledger India, which talks about and shows the functionality of the actual class manager infrastructure, how that loads into Hyperledger and loads on all the nodes and such. What Dave is going to go into is actually more on these lines, where we're going to, the blockchain will be up, the Hyperledger will be up, the nodes will be up, and we'll show how classes are created and instantiated in accounts and then making transfers. You can go to xbom.io, and at that point, we have 3 videos at the bottom of the overview link that go deep into the first part of this. What is a class mod? What is a first class object model? How do objects and classes, the concept, work within a blockchain? And then of course the inspector, so that you can get all class information, object information from the tree. And I will go ahead and pass this over to Dave now. If anybody has any questions, please ask. Real quickly, it is for the developers, all class build code is open source. The enterprise, there will be a per node SaaS license in order to interact with those classes that are built by the developers. No royalties taken from Prasaga on that. All revenues that a developer can make off of that goes to the developer for licensing. Ours is just on the CMI. And then just Corky, and I'll leave this up for a second because you can reach out to Corky absolutely on any information going on. He's our CRO, Chief Relationship Officer, Chief Revenue Officer, but we're not for profit, so we call them relationships, right? And all the information is there, and we'll put this screen up again at the end. So I'll end it there. And if there's any questions before Dave starts, please do ask.
You have to stop, Gid.
Yep, there you go.
Okay, so I'll come up. All right, so what Mike just said, one of the core pieces here is that a lot of this will make sense if you've seen the earlier videos. I've done a voiceover talking through just basically how the system comes up, how the class manager infrastructure is loaded, that type of thing. For background, since everybody's used to the term chain code, the class manager infrastructure is the chain code. It loads as chain code. Everything else is then dynamically loaded as shared objects into that environment on demand. And this is a big difference from just running chain code. If anybody wants to really get into Golang to figure out how to do that, that's an interesting problem that we worked out, but it does work. I mean, it's pretty stable. It's very stable, it works very well, and the environment's very stable. Golang itself as a language is a little bit verbose and let's just say a little difficult. What I'm going to do is show you what I'm going to show you what I'm going to do. I'm going to do it, then I'm going to tell you what we did, right? So this is what it looks like right now. Get that over here. This is what you call the foundation classes. There's a handful of others, but for this conversation, there's a class object, there's a class XBOM, there's a class XBOM container, and a class account. These have all been loaded into a running Hyperledger setup right now. I'm literally running the test network script itself to set this, so it's a couple of nodes and whatever it's using. I think it's using Raft or something for consensus. Then these are actual shared objects that have been loaded into the environment on top of the class manager infrastructure as part of the init. In other words, it's kind of, you have to bootstrap somewhere. Before I go into further, the class object is the root of all objects. Right now, this is a single inheritance where you can do abstract classes and interfaces. We haven't implemented multiple inheritance, but we will eventually. Class XBOM is the root for all XBOM classes. Class XBOM container is it's like think of it like a window container. You put you put a layer windowed environment, so each window contains child windows, so on. So this is the object that you would inherit from that could contain other objects. Class account inherits directly from class XBOM container to actually implement that containment model. So what we're going to do is we're going to load a new class called class fungible asset. Once they're loaded into the environment, everybody can use them. It's set up that the classes are now part of the blockchain. They're not, and they're loaded dynamically at each node. For any transaction use that might say use inheritance from some classes, it will go pull them into the environment so it can run. So that's a key point here, is that think of these, each one of these shared objects is completely separate on the blockchain and maintains inheritance through them. So we're going to load a class. We're going to create an instance of that, which is a first one I called asset1 because it doesn't have a name. I'm going to create I'm going to take that asset and I'm going to create another object where it takes something from this asset. So it started with 20 count, and now there's 15 and 5. Now what I'm going to do is create a couple of accounts. I think actually technically we've already created the first one. I'll create the second one. I'm going to move this asset to the new account. So what happens if this is literally the concept of moving assets back and forth and adding and subtracting. The way we've set this up right now for class fungible asset is that once it's instantiated, once you instantiate an object, the total count is fixed. So no matter how many times you transfer assets around, the total number of assets will always stay the same. That's kind of like a TGE on a smart contract type thing. We're then going to do something a bit more. We subclassed class fungible asset. That's actually written wrong. That's supposed to say class smart asset, sorry. And I'm going to create a couple of smart assets. What's different about them is you can name them and they have a unique object identifier. The way we work is that every object has what we call a ledger object ID. So every class, sorry? Yeah, every ledger object ID, every class and every object has a ledger object ID. They're unique across the entire blockchain. In this case, we can also then give them an internal name that's hidden from everybody that makes sure that they're unique, so that when I do this and create another asset of it, so then I've taken 7 and put them in here, these are completely separate from anything from, say, another asset name. Okay. That's basically it. Now what I'll do is walk through, show you a bunch of scripts to do that. Now we are doing all of this from the command line using the peer node. This is all JSON though. There's nothing wrong with running this to a, you could use a JSON interface for it. The existing libraries for Hyperledger would work with it. The other important thing, which I'm not going to demo here because it's in one of the other videos, is that as you load new classes, you're actually creating new API. So it's similar to the Open API capability. You can inspect a class, an object rather. It'll give you all its class ancestry in all of the input and output arguments and methods that you can send on them. Now, it gives you full schema. In other words, the only downside to that schema is that it's not conforming to the Open API right now, but we'll make it do that in the future. Okay, so this is up and running. I didn't run the startup things for it, but if you look at it, you can see that I've created a few new things, and I think there's a init. I'll scroll backwards through here. Can I find it? Yeah, there's the init from, we're running 2.0. Oh, one other thing I forgot to mention. This runs as an external blockchain, external chain code. It's not, you can't run it internally because the way that at least the 1.x version built the chain code is that it would force a vendor operation, and it was doing it by hand, and you can't do that and make the shared objects work correctly with the Golang because there's conflicts with the package names. And that's just, it's nothing to do with Hyperledger at all. It's just a Golang limitation. So we use the external builder approach, and we launch it that way with a handful of scripts. That's all written down in the getting started online for Hyperledger. Here I'm calling the init bootstrap, which loads these types of classes and a few others, so your class foundations are all set up. And then this just literally created a new account. So there's actually an initial account, even though I don't have it on here. So now we're going to do the first class load. And this is what it looks like. Everything I'm going to do is cut and paste over from here. If you notice, there's this long string of numbers. This is the ledger object ID. It is a 256 SHA. And then I continually hash it each time so that you're doing a unique numbers the entire time. And then I'm also verifying that each new ID it comes up with is unique against anything else sitting in the database. And so what I'm doing is, this is the system account ledger object ID. Sitting over here is actually the other. This is saying what object to send it to. The way the transactions work is you always specify the account that you're sending a transaction to and the object in the account that you want it to do, and then you're sending it the method that you want it to call and the parameters. The parameters are done explicitly as a JSON, because what I'm doing internally is using JSON decode to take these strings out, decode them, do the operation, make the method call on the objects, and then the result is being re-encoded, so you get it back as JSON. So let's run one. If I can get the, hello, where'd it go? Yeah, I gotta go a little down like this. There we go. and just straight cut and paste. So it does a straight call, returns the output, and it now says I've created a new, I've loaded a new class. When you load the class library, there's a function that it calls called create objects, where it'll create new classes. It's all in the source code. And you can see examples of that in the GitLab sources, although these classes have not been up there yet. I will be uploading them and adding to the README there, but all the basic functionality is the same. These are just implementation pieces. And so I've now created the fungible assets. So in this slide, we are here. I haven't created the asset yet. I'm about to do that. And that is, you'll notice that it says new object, asset count over here. And it actually wraps around, but I'm going to create 20 of them. So it's as though, that could be, a million count of whatever you wanted it to be. It could represent anything from, screws from a screw factory to financial assets. Command. And what will happen is, you did a create. If I hit return, that is. And it just says I created a new object. Here's the new object. So now that's an object instance. So I've instantiated an object from a class. Remember, it's a first class object model, so the classes are actually objects as well. So what I actually did is I sent a message to the class to create an object. So that's how that works. There's a meta class actually in this environment called class, which is also subclassable. So you can create your own classes that create classes if you really want to. And there's reasons to do that. I'm going to prove that the numbers are currently in here. So I'm going to ask it, I'll do it this way first. I'm going to ask it what its current count is. Calling that method. Paste. Return. I'm going to put this window up a little higher. And you'll notice that it returned, and here's what's returning the JSON syntax. And the parameter was asset count. That's actually what is in the output argument data structure. If you dumped out the schema, and of course equals 20. So this now works. So now the next thing is, I want to take that asset and I want to take some of it away and put it in another object, so I can take that object and put it in another account, so that I have so we have a way to move assets around. So the first thing you need to do is be able to make a copy of it with a new asset count. And that's with subtracting out the accounts from the previous one and adding to it. And that's this call. Whoops, I think here's the new asset method right there. It's going to make it from 5, and I'm giving it the object. I'm sending it now to the object they just created, the asset they just created, rather. And you can see this number. Here's a piece of it here. Here's the same number here. And it made a new object. So we now have this. So far I've loaded class code and I'm just using it, dynamically loaded in. It's currently being loaded, by the way, from a path to a file system, but there's no reason why that can't be set up as a URL or a search of a URL. You could have multiple locations for backup. For prototype purposes, it's a local file system. I'm got the container up, set up the Docker Compose to go look at a local file instead, local directory rather. And you could even, NFS mount that or some other Samba or something like that. Okay, so there's the new asset. So we now have a new asset. Where am I? Right. So first thing I'm going to do is show that the two counts are now changed. So here's the first one. Come on. And so I now have an account of 5. And where did I just do that? What did I just do? Yeah, that's right. Okay. And, oh, this is the other one I need to call. or I'm confusing myself, which would be the first time. Nothing like doing that in the middle of a demo. Right, so the original object now has 15 instead of 20, as you would expect. You know, simple math, adding and subtracting. Amazing that our computers can do that. Okay, so now what I'm going to do is create the account that it's in. So as I said, the first account already exists. I just didn't put it in the diagram. But I'm now going to create this. I need an account to put the objects in. So I'm going to create one. Obviously, you would have one, but for a demo, I'm just running it through. And, you know, and the call is to class factory, which is the factory factory design pattern. It's actually in the inheritance tree. I just didn't put it in for simplicity purposes. And now I've created a new account, and this is the account ID for it right here. You can actually ask it to do multiple accounts if you want. With the new count parameter, I can say create a whole bunch of these. And the factory design pattern can be used for other things too. You know, you know, these are all foundation class capabilities. So now I have an account. I'm simply going to put the asset into the account, which is right here. It says transfer asset. Here's the account object. And it's, you know, anticlimactically going to say, yep. And here's the asset object that it moved. Returns that. And then I'm going to ask using the ancestor inheritance to the XBOM container to show that it's now a child of that account. So in other words, it's now owned by the other account, by the new account. And that's going to return back. Here it is. What I'm going to do later is show you actually ends up with, I add more than one type of asset into the same account. See, the nice part about that is there's nothing in the containment relationship that says I can only have one asset or one type of object, and I can put anything I want. So you can create all sorts of protocols. So the next thing I'm going to do now is load the smart asset class. So dynamically loading this, which is again a Go shared library. Let me pause for a second to show you, where are they? Can you do that? Yes, so these are actually the classes. This is the directory that I set up to Docker compose, and these are the shared objects, Go shared objects. Then so that they're not, it's not part of the tar.zip for doing doing the external build. It's not built internally. They're literally just externally available. At the moment, I don't do anything that verifies hash, you know, to verify that it's valid code or anything that's not been tampered with, but it's easy enough to do. Okay, so we're at this point. Whoops, I can't. Oh, it looks like I've created the smart asset, but I haven't created the assets under it yet. So I'll just go do those. So here I'm going to create one called DGT. Here's the asset type, which is part of the class smart asset, but it also inherits from class asset. So I have another parameter here for setting it to the count to 20 on this one. If you'll notice, these numbers are saying, here's the class that I want to, in the initializer, in the parameters for it, the ancestors, and here's another class that inherits from, and the parameters I want to initialize there. So we do regular inheritance, just like you would do with any other language, only it's done dynamically on the blockchain. Do the same thing here, paste. As you, if you watch through the videos, the other things will explain that this is actually being written out to the database, and it's using these numbers, the ledger object IDs, as the keys to the database. So I just created a new object that's of class smart asset with DGT of 20. And that's right here, the screen guy. And where are we? And let's create the other one. I made up a name, call it wrap teeth. These string names, that's that field for this. This is a demo, but that's just a string field. Could be anything you want in there. It's an unformatted string. Of course, you could subclass this and put any sort of format you want in there as well. Just wanted to make it as easy as possible and clear. So now I've created a second object. So I now have both of these, and they're actually owned by the first asset account. And you can see that it's actually, this is the account that the message was sent to. Remember, account plus object. So you always specify the account and the object. There is a small bit of a way to think about this. Is there's something called object call, something called object send. These are names that I used from a language, an environment from the early 90s called Penpoint. I happen to like it. People can come up with better names. Send means that you're moving into the context of the target account you're sending the message to, whereas call means you're staying in your current account and you're sending a method to an object that a class that may not be in your current account. And obviously you can't do the call type thing if the data you need is in the other account. And so there's there's flags to turn on and off whether or not an object call or an object send is allowed on any given class. So I'm going to go show that I just created the asset types so that you can now ask the smart asset, what are you? It's going to tell you that this one is a DGT. Okay, and we're going to do the other one, which is going to tell you that it's the wrapped. But these are arbitrary strings, and somebody could try to, make more than one of these. And then you get into all sorts of funky behaviors and lying coins and all that type of thing. So internally, they have a ledger object ID that I'm calling a UID for unique identifier. And so let's ask it for that. And here it is. Here's its number. And this is an internal number. It's not an object. It's just a number that's unique among all objects and every other ID because I'm comparing it against everything else to guarantee it's unique.
Hey, Dave, we do have a question in the chat here right now.
Cool.
So from Jayakar here, we have.
I see it.
I can just read it to you.
Okay.
So in a network of native hybrid cloud server network of nodes for a global infrastructure, if we have Cloud Foundry replacing the network operating system, what would be the architectural change that you would recommend in that case?
Read that again, because I think I think it's missing something. Ask that again, please.
Sorry, Jayakar, if you want to just ask it yourself here, please feel free to unmute yourself and ask it. Maybe not, but.
Yeah, Dave, you can click on the chat window as well to read it if you can.
Where's the chat window? I got, I'm sharing my screen. I can't see anything.
Oh, got it. Okay.
Wait. No, even when I put up here, all I get is.
Okay, let me.
Pause. I can't see it. Oh, wait. Chat.
If you mouse down, it should pop
I found it.
Okay.
Okay. In a network of native hybrid cloud server network of nodes, native hybrid nodes for a global infrastructure, if we have Cloud Foundry replacing network operating system, what may be Cloud Foundry as in the company is Pivotal? Interesting. So you're talking about containers and you're running Docker images and containers, that works fine. I'm not sure if you're asking for the architectural change to Hyperledger because there's none. This is strictly a configuration and you're loading chain code. Everything else works as is. until you start, of course, doing these types of messaging. So literally you're just running Hyperledger. It does have to be 2.0 and above. And there's a couple of configuration issues. One of them is that your underlying operating system, the default for Hyperledger, at least in the open source, is using a very, very limited Linux version that doesn't have shared object loading. You have to replace that in the Docker image with an actual one that'll do shared object loading, otherwise it can't do it. The other thing you have to do is set the config.yaml to use external chain code. There's a model for that. Other than that, you can see the rest of it in the GitLab for it. That's basically about it. If you're running your Hyperledger construct with Cloud Foundry and rolling out containers that way, you'll whatever consensus algorithm you're using, as long as it works, will work fine, because we're sitting on top of that. I don't know if you call that a layer 2 or above, but we're literally, as far as Hyperledger is concerned, it's just maintaining the replicated database. Nothing changes there. Hope that helps. Okay.
Thanks, Dave. That should help.
Sure. And I'm just going to show the other one. Yeah, we actually have had conversations with a couple of the majors about putting it into their environment. One of them wasn't actually ready yet. They were running a 1.x, and unfortunately you can't do external chain code 1.x, so we couldn't get around it. As you go to 2.0, 2.x and beyond, you can. Oops, somebody else responded. And real quickly, I'm just showing that these, before I get there, that the two UIDs are completely different from each other. Here's the other one. And where is it? I got to scroll up to see it, but I don't know if I can get my thing to scroll. Yeah, come on. Really slow scroll. Okay, to hell with that. In any case, they're different. I'm not going to waste the time on that. Okay, did somebody else, somebody I think asked a question and then it, yeah, there it is. I'm a rookie Hyperledger. What are the numbers in the arguments mean? Oh, so these are not specific to Hyperledger. They're specific to the class manager infrastructure chain code. We create a unique identifier. We call it a ledger object ID. For each object, whether it's a class or an object, an instance of a class, which is an object, you need some way to reference it. So the database model for Hyperledger uses a key, a keyword and a key value capability. LevelDB does that. CouchDB does that as well. CouchDB does a few other things we're not using. What we did is we set the key to be this value. And it's being printed out in JSON syntax as an array, but each one of these is byte. I'm sorry, it's 256, so it's 32 bytes. So it's a 32 byte number using the secure hash SHA-256, which is the standard way to do a low collision hash capability. And so I'm just chaining for everyone. What happens is, given the previous hash number, you use that to generate the next hash number. That's going on internally. And then it's guaranteeing it's unique just in case there was a collision by also checking with the database, do you already have this key? If so, it'll pull another one up. So that's specific to, this is one of the keys to making it possible to have a dynamic object environment like this, because you need to have the objects themselves have guaranteed unique references at runtime. That's how we're doing it. That's actually one of the core pieces that make this possible. Without that, you can't. Without that, you can't guarantee uniqueness, and therefore you don't know what you're sending messages to. Okay, I'm going to then prove that the assets are there. This is the get asset count in the newer smart assets. The thing about this is, the nice part of that is once you create the code and load it, anybody loads it, everybody uses it. So you only, in general, you assume that we'll have a large enough environment of classes already on the blockchain, so that your job really is to create objects and instantiate them if you need to configure things together. So you don't spend a lot of time, well, you don't spend any time with the code. And that gives you a nice way to avoid, typos in your code and errors like that. So a lot of it can be reviewed once, and we haven't done it yet, but it'd be something you'd put a certificate to it and run. Oop. So the answer to this question, on an already running network, or would it be separate? So somewhat yes, somewhat no. So as long as you can load if your Hyperledger nodes are configured correctly to be able to dynamically load shared objects, which a lot of them may not be, but if they were, and you can create, say, a new channel, you could certainly load this CMI into it, class manager infrastructure. The other problem, though, is you tend to have databases that have already been set up with some sort of configuration, whatever your records look like. What you could do is front end those with objects that represent them and then use methods to them. So you'd write a class knowing what your objects already look like and be able to load and interact with them. We've already thought through that that's possible. The one that I don't know if you could do is, given a running channel, can we load the CMI into it and not interfere and have a non-interference with the existing chain code in that environment? That's one to look for. I think it's probably case-by-case basis. Theoretically, as long as they don't interact with each other, sure. But then you have an issue where if you have the same objects hitting the same database, hitting the database is fine. If it's hitting objects, key values in the database you're already using for something else, with the other chain code, you might mess something up. That's somebody has to code it for you. But theoretically, as long as the configuration pieces are there, as long as you can put the external chain code model in, sure. Maybe because a lot of these can bring the nodes down, change these are config flags in the config.yml and bring it back up. You probably do it that way also. Take a little bit of work, but not impossible. Okay, so I proved that the asset counts here. Cool. Questions are good because the rest of it is just me demoing it. Can X-BOM class interact with existing chain code already? Oh, got it. Thanks. Okay, cool. Thanks. And let's do the next one. Unfortunately, blockchains running in command line or even in a thing are not really great whiz-bang demos. But where'd it go? Yeah. What just happened? Hello. UID again. So I was going to do this guy. Let me do this guy. Okay, so what I've done is shown that one is 40, one is 20. So I'm going to hit those right with the interruptions. What I'm going to do now is take the DGT asset, and I'm going to do the same thing as the previous thing, and I'm going to bring this down. So it's like this. I'm going to take 7 out of it. I used a different number to make it clear that there wasn't some, magic. They happen to use 5 because that works or something. So here we go. So now I've created a new object that has, and here's the object ID for it. And to prove that it now has 7 in it, we go to this guy, which says get the asset count. I mean, obviously, one of the tricks for these unique IDs is that the seed that I use at the beginning is fixed when I start this up for a demo. In the real world, every time if you're going to start a new Hyperledger chain up, you wouldn't do that. You would pick a random value, and there's a function to let it pick a random value. You can give it a random value, and then that'll be the seed forever. But of course, for demos, I can't make scripts if the UIDs change all the time. So I just did that nice and easily. Okay, so I proved that there's 7 in the new one. I'm going to prove that there's 17, 13, it can subtract. In the old one, whoops, that was the wrong message. That's the get asset type. Oh, I guess I didn't ask the new one. I'd have to rewrite that. Here's the get UID. The reason why I want to do that, show that it's the same UID as the original asset. So that this number for both the DGT over here and the DGT7, both of these have the exact same reference inside them. That's important because that means that I can't, take one asset and add it to another asset type. So now I'm just going to move this asset to the other account, and that's literally same transfer asset, same method that I called for the previous one. Two different asset types, two different classes, subclass inherited, all of it works. Moved it. Now, of course, I have to prove that it really moved it. So I'm now going to ask the account, it's containing the, because remember the account inherits from the XBOM container, which implements the concept of containment. Copy and paste. And what you'll see is two objects now. This is the original one. This is, remember, I just put this asset in here. And now here's the second asset because I returned an array of all the object IDs that are children of the main object. So this is the account object. And this one is, this guy is in there. And I believe that's it for the demo. What I did want to do, actually we're supposed to be an hour, we're actually out of time. Any questions then? I was going to show a little source, but I think we're probably out of it.
Yeah, Jim Mason, a couple of things that strike me. First question is, just to be sure I understand this right. So I'll call it the framework that you have is in a sense free as open source that we can add on to an existing Fabric environment, right?
Yes. Two things about it. Yes, it's intended to avoid ever changing any of the source code in Hyperledger. The second part is that—
I'm not worried about Hyperledger though. I'm not worried about Hyperledger. Leave that alone. Just say it's a runtime. Assume it's a runtime. What you're doing basically is saying, here's I'll call it a free open source stack, if you will, that you can add to Hyperledger. And within that environment, if I have this right, you can, in a sense, create your own classes and objects that will be dynamically defined and invoked, where normally we would go through a chain code deployment cycle to deploy, I'll call it changes or new contracts kind of a thing, correct?
Right, you do it, yeah. You bring up the chain code, you never need to bring it down. Absolutely. Another piece of— Sorry?
If I could just real quick, Jim, Michael Holdman here. Yeah, it's the class code to build the classes and objects for the developers that want to create apps to sell to enterprises. That is open source. At this time in the Hyperledger environment, the CMI, it's free to use, but it is binary. It's free to use for the developer. But the enterprise does pay a license fee, a monthly license fee per node for that class manager infrastructure once it goes into a test.
All right, so in effect, I'm licensing, right? So to your point, I need to license the CMI runtime for development to run it in I'll call it a business application. Number one, but what's really strange is using Go, which is a language that has no classes, to define a class-based network, which is really strange because there's a lot of great, what I call more dynamic languages than Go, far more, that make it easier to develop those kind of things for DSLs and stuff. And for some reason, you didn't go that way.
Right. So normally you would do something like take Python and modify it.
No, I would use something like Groovy that's really dynamic and class-based, right?
Sure. The reason why is that when I started out in this, Hyperledger had Go. That was the only reason. I started with the language because that's what it was, and okay, I'll deal with that. It's not really meant for it. I jumped through hoops to work through its type system. I use unsafe types and things like that, but they're all heavily wrapped, so you don't really have to touch them.
Yeah, I understand that, but like I say, that normally, because I built languages like this in the past, and in doing those, it made sense to start with a higher level object-oriented language by far. It made it not only productive for me to build the framework, but also far easier for the, what I call consumer, the developer I was targeting, to in a sense describe his own dynamic classes and objects at runtime, kind of a thing.
Yes, with the exception of the fact that this is using a class manager library approach, so you need to integrate any existing class-based language with that environment. Some of that would probably be the equivalent of doing Java native callouts to make the transition over to it. But yes, that's about the rest of it.
Well, actually, so that's one way to do it. I'll say there's other ways that are a lot easier to do it than that, but that is one way it could be done. You're right.
Yeah. Basically, you have to modify the language slightly to support it, yes. The short answer to this is I started with Golang because Hyperledger at the time, that was what they set up. They have since added JavaScript and Java, I think, into it, and I don't know what else they have because I haven't looked at the site in a little while.
They have more coming, but you're right. Java and JavaScript or Node.js are the only other two that are what I call really stable at this point, in addition to Golang.
Yeah, so I could have taken JavaScript probably to do it that way. I know Java very, very well. I'd be writing some Java native interface to make that one work. Literally at the time I started this, though, neither of them were stable or available. So Go was there. I said, aha, so the rest of Hyperledger is written in Go. So I'm going,
actually,
written in Go,
I bet you,
these pieces together.
Right. Anyway,
that's all it is.
Yep. Okay.
Okay. Any other questions? Or did we're coming up on 2 minutes to 1. This is a 1 hour shot, I believe. If anybody's interested, you can go to GitLab. You can go to our XBOM.io, register. It'll give you the link to the GitLab, and you can see all the sources for a good number of these. They're not all up there yet. Some of these I haven't uploaded the latest version. You'll only see the part that brings it up to the class account and basic objects. The rest of this will show up shortly. And then there was one other comment. The other thing is that in this type of environment using Golang for this, the actual shared object, the actual classes are compiled. You were mentioning about a dynamic environment. So yes, we made Golang actually look like a inherited model class environment with dynamic class capability. It's a little funky.
Yeah,
but,
it is really funky. You're right.
Demonstrate the concept. By the way, what we were after is demonstrating the concept of using the blockchain as a means for doing inheritance on classes. So you can create an environment where every time you bring up a new capability, you don't have to write an entire smart contract and hope that you're getting all the right code. It's already on the blockchain. You're only using it. That was the fundamental reason for it. There's some other reasons that have to do with performance as well that are outside this conversation. One more kind of question, and then I'm going to have to drop 2. Any LLVM optimization? No. What's in the roadmap is to get rid of Go. This is we're proving it out. I think that long term, we're not going to stay with Golang. We might keep the class manager infrastructure in Go and then interface other languages just being discussed. That's all. Okay, I actually have to drop, but thank you very much, everybody. Hope this was interesting and useful.
Thank you both, Dave and Michael, and the rest of the Prasaga team. Great presentation, and we can ask everyone else to feel free to follow up with you guys if they have any questions or want to learn more. And again, everyone on the call, feel free to reach out to myself if you want to present at a future meetup. And we look forward to the one next month. Thanks, and have a great rest of your day.
Yeah,
Thanks a lot,
thanks for
everybody.
inviting us and listening in. Awesome. Thanks, guys.
Thanks, Chris and team.
Take care, all.
Bye-bye.
Thank you.
Have a great day.